Good morning, students. So, I have already sent one video about today's lecture, but in that you have one concept which is called as color coding. So, for the more clearance about color coding, I am creating one more video over here so that you can understand about it more clearly. So, that color coding is very important concept. If you have not understood it yet, watch this video carefully. So, let's start with it. We are studying about color coding of resistors. Students, I have already told you there we have three factors: resistance, resistivity, and resistor. So what's the meaning of all three factors? I have told you. Resistance is one property. So resistance is one property of the conductor, and resistivity is the phenomena taking place in the conductor. Because of resistance, resistivity is taking place in the conductor, and depending on these factors, practically if you want to show the resistance and resistivity, we'll use the device which is called as a resistor. I have shown you already the picture. So this is the device called as a resistor. This we are using in our physics lab. When you will come to the lab, you can see it. Okay, so this is resistor. It's a very small device. So see here. So resistors are very small devices which we are using in the electrical circuit. Okay, so what the work of this resistor in the electrical circuit means, as you already know, resistance will oppose the flow of electrons in the conductor, or it will oppose the flow of electric current in the conductor. So the same work is done by these devices. Okay, so these devices will oppose the flow of electric current in that circuit. Okay, so if in any circuit, if you are using resistor, that resistor will oppose the flow of electric current in that circuit. Okay, so watch this resistor carefully. So this is having very small surface area. The surface area of the device is very small. So here they have told that 10k ohm is the resistance of this resistor. The value of resistance of this resistor is 10k ohm. But that 10k ohm they cannot write on the surface because it's very small in the surface. The dimensions of the resistors are very small. So that's why they cannot print this value of the resistance on the surface of the resistor. So instead of that, what they are using there, they are using some color bands. You can see here. So here brown is there, black is there, red is there, and gold is there. 4 bands are there. 4 bands of colors they have shown. Okay, so by watching these bands only, we should get the value of resistor of that value of resistance of that resistor. Okay, so we should know how to read these bands. 4 bands we have here. How to read these bands we have to understand. For that only we are using the procedure color coding. Okay, so the reading the resistance of the resistor is nothing but color coding. So how to read them? So whenever you got one resistor in your hand and you want to get the value of resistance of that resistor, you should follow the procedure which is called as color coding. Okay, so now I told you. So in the color coding, we are I'll draw one table over here first. Okay, so as I told you, on the surface of the resistor we'll be having 3 to 4 bands, minimum 3, maximum 4. Okay, 1 2 3 4. 4 bands will be having on the surface of the resistor. Okay, so the first band will represent first digit of the resistance. The first band will represent first digit of the resistance. The second band will represent second digit of the resistance, and the third band will represent the decimal multiplier. The third band will represent decimal multiplier. Okay, and the fourth band will represent what? Tolerance. So all the 4 bands are having their own significance. Every band will represent some factor over there. Okay, so by using this only we should read the resistance of that resistor. Okay, so the first digit is given by first band B1, second digit is given by the second band B2, the third band B3 will represent decimal multiplier, or you can say the number of zeros, 10 raised to 0, 10 raised to 1, 10 raised to 0 means it's 1, 10 raised to 1 means 1, 10 raised to 2 means 100. So what are the decimal multipliers you have to use there, that is understood by the third band B3. Okay, and the fourth band, this will represent tolerance. Tolerance means nothing but what? It's a limit of accuracy. Tolerance means what? Limits of accuracy or permitted variation. Permitted variation. Tolerance means the limit of accuracy or permitted variation. So this is the basic idea. Okay, now let's now just draw the table. So we have a table over there. Okay, so in the first column what I am writing about the colors, and in the second column I am writing the number, in the third column decimal multiplier, and in the fourth column we have tolerance. We have to write a tolerance in the fourth column. Okay, so for students, to understand, to remember the colors, we have a particular procedure there. So I will tell you a trick to remember that colors. So how you have to remember those colors means, you just remember the first letters of those colors. Okay, as I'm writing here, B, R, O, Y, and then G, B, V, G, W. Okay, so how much colors we have over there? 10 colors we have. 10 colors. With respect to those 10 colors, we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you have saw in that picture already that you are having there gold also. The color of gold also is there. So let write here gold and silver. Okay, so what these letters represent now? So first B will represent black, brown, red, orange, yellow, green, blue, violet, grey and white. So these are the 10 colors we are having. Okay, so how to remember these letters? B, R, O, Y, G, B, V, G, W, G. B, Roy. B, Roy of Great Britain had a very good wife. So let construct one sentence. B, Roy of Great Britain had a very good wife. B, R, O, Y, G, B, V, G, W, isn't it? So let construct. So by using this sentence, you can remember these letters. Okay, so this is just one trick. Okay, so now, so for gold you don't have any number over there. Now look at the decimal multipliers. 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3, 4, 5, 6, 7, 8 and 9. Okay, so for this gold we have the decimal multiplier 10 raised to minus 1 and 10 raised to minus 2. So you can watch it carefully. So like this we have the table like this. So you can watch it. Like this we have the table. Okay, so So this tolerance is given only for the gold and silver, not for the other numbers. We have the tolerance not for any other colors. We have the tolerance only for gold and silver. So for the gold we have the tolerance plus or minus 5%, and for the silver we have plus or minus 10%. And I already told you, you might be having only 3 bands over there. So if you have the only 3 bands, the fourth band will be not there, so you consider there none. If there is no fourth band, you have to consider the tolerance as a plus or minus 20. So now the respective colors, to that with numbers, decimal multipliers and tolerance I have told you. This table I will send you in the notes also. You watch it carefully. Okay, so now you just consider one example. So in one example, let's consider on the register you have 4 bands over there. So the first band is blue, second band is yellow, third band is gold, let consider, and the fourth band is silver. So how to read the reading now? So the first band you are having blue is having a number 6. Okay, yellow is having a number 4. Okay, and gold is having a decimal multiplier 10 raised to minus 1. And silver is having a decimal tolerance plus or minus 10%. So if the resistor is having these much colors, its resistance is given by 64 into 10 raised to minus 1 plus or minus 10% ohm. Why ohm? The unit of resistance is ohm. Okay, so if you have blue, yellow, gold and silver colors on any resistor, its resistance is 64 into 10 raised to minus 1 plus or minus 10% ohm. Okay, understood? So now let's consider some examples. Okay, so now, this is one resistance, this is one resistor. So on that resistor you are having 1, 2, 3, 4. 4 bands you are having. So for the first example, let's consider the first band is yellow and the second band is, let's consider it's gray, and the third band is red and the fourth band is let's consider gold. So now you look at the table. So what is the number we are having for yellow? We are having the number 4 for yellow, and we have 8 for gray, and for the red we are having the decimal multiplier because the third band will represent decimal multiplier. So for the red we have decimal multiplier as 10 raised to 2. And for the gold we have the tolerance plus or minus 5%. So the resistor which is having these colors on its surface will be having the resistance 48 into 10 raised to minus 2, 10 raised to plus 2 plus or minus 5% ohm. Understood? So you try to solve some more examples of this type. Okay, so let's consider one more example by taking the numbers. If any one resistor is having the resistance 49 into 10 kilo ohm. So if the resistor is having the resistance of this, so you can find the colors of that resistor now inversely to this. So fourth number is having which color? Look at the table. We are having yellow for the fourth number, and for the 9 we have white, and 10 raised to k ohm. 10k ohm means 10 raised to 3. So for 10 raised to 3, which color we have there? Orange. And we don't have any further readings. We don't have tolerance here, means the fourth one is nothing. So we don't have a fourth band over there. So we have to, so there is nothing. Okay, so yellow, white, orange is the color coding of the resistor having this much of resistance. Understood? So this is about the color coding procedure. Okay, so let revise some points which I have covered in today's video. In today's video, I have carrying forward the Ohm's law explanation I told you, and we studied about the dependence of resistance over there. So on which factor resistance depends, I told you in the today's video. So R is directly proportional to L, R is inversely proportional to 1 by A. By combining those, I have got L by A, and I have written there the rho as resistivity. So this rho is nothing but resistivity. So we have got one new factor over there. So what this rho is, nothing, rho is the value of rho, we can write it as rho is equal to R into A divided by L. Rho is resistivity of the conductor. Okay, so how we can define this rho? So now if the area becomes 1 meter square and the length becomes 1 meter, this rho is equal to R. So the resistivity of the conductor is numerically equal to resistance of the conductor with unit length and unit area of cross section. Understood? The resistivity of a conductor is numerically equal to resistance of the conductor if with unit length and unit area of cross section. This I have told you, and I told you that this rho depends on nature of material of the conductor. Okay, so and also it depends on the temperature. So the temperature dependence of resistivity is given by one equation. Rho is equal to rho naught into 1 plus alpha into T minus T naught. So this rho is resistivity at the temperature T, rho naught is resistivity at the temperature T naught, and alpha is temperature coefficient of resistivity. And we have defined alpha as, how we have defined alpha? Rho minus rho naught into T minus T naught. So this we got from the explanation. Alpha is rho into rho minus rho naught into rho naught divided by rho naught into T minus T naught, or also you can write it as del rho divided by rho naught into del T. So how we define the temperature coefficient of resistance? We have defined the temperature coefficient of resistance alpha as the change in resistivity per unit change in temperature per original resistivity. This rho naught is original resistivity at the temperature T naught. T naught means 0 degree Celsius or 273 Kelvin. So this is the change in resistivity per unit change in temperature per original resistivity. So this is alpha. Alpha is temperature coefficient of resistance. I have told you, and I have told you the value of rho changes for the value of rho is different for different materials. On depending on the value of rho, we can classify the materials as conductors, insulators, and semiconductors. Depending on value of rho, we can classify the materials like this. So how means the resistivity of conductors is very small. In resistivity we have very small conductor, that is 10 raised to minus 8 ohm to 10 raised to minus 6 ohm, and the resistivity of insulators is 10 raised to 18 times greater than the resistivity of the conductors. And obviously the resistivity of semiconductors lies between conductors and insulators. This point also I have covered in the today's video. Okay, so I thought that in today's video my voice was not that much clear, that's why I am sending one more video here for your better understanding. Okay, so still you have any doubts, you can ask me or you can contact me in any way. Okay, thank you. Watch the video carefully, and along with this I am sending the notes also. I am sending the notes from Ohm's law to color coding. Okay, read the notes carefully, watch the video carefully. If you have any doubts, ask me freely. Okay, thank you.